I'm going to review the espresso procedure and push it forward a little bit. But before I do, I want to back up and just talk to you a little bit about the numbers that I'm using to both model and animate the solar system. I arrived at some basic notes just by jotting down some basic information found at that 9planets.org website. So if I just launch this 9 planets, basically what I looked at is the first thing I did was I jotted down the order of all the planets, right? Just so I wouldn't get these mixed up, and I had a reference. So I, have Mercury, Venus, Earth, and so on. The next thing I did is I went in and I looked at all the diameters and I wrote those down. And basically, so if you remember, we started talking about the scale of things. That diameter of the sun just really wouldn't make any sense, because if we, in fact, let me just take that value again. My strategy, let me back up here and I'll jump into Earth. My strategy was rounding the diameter numbers down to, I took the number of 12,000 kilometers and I made it 120 centimeters. So I didn't worry about the scale inside Cinema 4D, but I wanted to kind of start with just kind of a relative scale. And so basically what I did is I took that 1,000 number, okay, so 12,000, and I added a 0 to it, which gave me 120. So I quickly went in, basically divided the diameter by 100, and rounded that number down, which gave me these values. So I ended up with 120 for Earth. That same strategy I used on Mars, and I gave myself 60 for the diameter, and I started plugging those values in. Now, that just gave me kind of a reference or a starting point. Okay, I'm going to tweak the size of these things and their placement. In addition to that, there is this notion of an astronomical unit, which just so happens that Earth is 1 astronomical unit, or 1 AU, from the sun, and that's the measure by which all the planets' distance from the sun are measured. And so you might want to jot those down. But again, if we model this thing accurately according to scale, things are going to get way knocked out of whack. They're going to be exaggerated, or they're going to be seemingly exaggerated to the point where we couldn't really fit in these things in an appropriate presentation or animation. If I jump back to the sun, I'll go back to the sun, and again, if this were to a relative scale, if I jump back in and I make that sun, let's say 1300. Excuse me, not 1300. According to my scale, it would be 13,000. Okay, so that's the relative scale based on the way that I'm modeling it. So clearly not going to work. So I'll bump the sun back down to a manageable size. I've chosen 500 to get started, but I think I'm going to want to make that a little bit bigger as time goes on. But I'm going to worry about that after I get a prototype or a mock-up of my animation. Okay, now let me review this espresso process. So just a little bit of review. We're going to model this solar system. We're going to animate it using espresso, and we want this to be at least in part informed by some of the facts of the solar system. And then once we get a concept of the relationship in the solar system from planet to planet, we can kind of disregard that and tweak this for design and presentation. Okay, so I'm going to select the existing espresso tag that I made in the previous presentation, and I'm just going to hit the delete key, and that basically removes any reference of espresso. Now, I still have the animation for the Earth orbit happening. Okay, and right now it's orbiting or rotating one time along its heading rotation. It rotates 360 degrees or one time in that 90 frames. Okay, so I'll just rewind that. So my Earth orbit is going to drive everything else. Okay, and so the way I'm going to do this is I'm going to select the Earth orbit, and I want to establish my espresso tag. So I'll right-click Cinema 4D tags, and I'll go down to espresso. That opens up the espresso editor window. I want to drag the driver animation in, and I want to drag, say, the first experimental object. In this case, we'll use Venus to experiment on. So I want the Earth orbit heading rotation to drive the Earth orbit heading rotation of Venus. And remember, we have the blue is the input, the red is the output. So I want to output the Earth orbit and feed it into the Venus orbit. So once I get these nodes established, I do need to define the data that's coming in and out of these things. So once I drag the Earth orbit in and the Venus orbit in, what I need to do is establish the output. I'll click on this little red tab here, go to coordinates, rotation, rotation heading. That gives me this little node that is now outputting whatever the heading rotation is on the Earth object. Next, I'll go to the Venus orbit, and I'll left-click on the input side of the node. I'll choose coordinates, rotation, rotation heading. And now remember, I don't want to just attach these two directly because I want one rotation of the Earth. According to my notes, I want it to rotate, excuse me, I keep saying rotate, I mean orbit. I want Earth to orbit one time while Venus is orbiting 1.5 times. Okay? So I can achieve that by introducing a math node in between these two nodes, and I'll just right click, say new node, Espresso, calculate math. Okay? So I'll just kind of drag these around to space them out a little bit more, so it's a little bit more visually friendly, and I'll attach the output of the Earth orbit to the input of the math node, and the output of the math node to the input of the rotation H on Venus. Now, I'll select the math node and go down to the attributes editor, and I want the data type to be real. That just means whatever number's coming out of this is just an actual number, and we don't want to add, we want to multiply. And in this case, I'll multiply by 1.5. Okay, now I am going to throw out some numbers, just some real simple numbers. I'll launch Microsoft Word, and I'll make this available inside the Solar System project. But the basic idea here is that I'm going to make just a real quick comma delineated database, if you will, of what the object is, what its diameter is, and what its orbit factor is. So in other words, in the case of Earth, its object name is Earth, its diameter is 120, okay, and its orbital factor is 1. We don't really feed that in anywhere. But for Venus, and I'll just move this up, for the Venus object, its diameter, I have to go check, see what it is. I think I used, let's see, let me select Venus. I'm looking at a radius of 115. Okay, so my radius is 115. My orbital factor is 1.5. So in other words, this is the value that I've plugged in to that math node. So if I double click, and again, I'm just sharing with you the notes that I've arrived at, kind of experimenting with this to come up with my proof of concept. And I'll share these numbers with you inside Blackboard. So I have Venus, and I'll just to see this part of the demonstration through, I'll show you my values for Mercury. Its diameter, or its radius, according to Cinema 4D, was 40. And my orbital factor is 4. Okay, so let me translate that information. We've already modeled it, and I've keyed in the value of 40. And again, you don't have to use my numbers. These are just the numbers that I'm going to use to kind of get things started, and I'll start to tweak them based on what my presentation is and how much, how fast and slow things are going. But this is what I'm going to use to get started. So I've already modeled Mercury. That has a radius of 40. The next thing that I want to do is I'm going to use this Earth orbit to drive the Mercury orbit. So I'm going to drag Mercury orbit in. Okay, now the difference is that I need a new math node here, okay, because I don't want this math node to be driving Mercury as well, because if I did, it would orbit the same as Venus. And so I'm gonna set up my Mercury orbit by left-clicking on the blue side of the node. I'm going to coordinates, rotation, H rotation. So I've prepared that to receive and translate whatever data comes out over here to equate that to its H rotation. Now, I need a new math node, so I'll right-click and say new node, Espresso, calculate math. And before I start connecting these things, I'm going to select my math node. I'm going to change the function to multiply. And my input is going to be driven over here. input number 2 is where we'll multiply this. I'll show you that in just a second. I can drive multiple nodes with one object, and so I'll just click and drag and draw my string from Earth orbit to this new math node, and then drive the output back to the rotation of Mercury. Okay, so I have my math nodes established. Now you'll notice that once I connect that first node, before I drew that line, I had math node input 1 and input 2, so I could just do some manual math in here, but again, I want this to be dynamic. I want it to be simulated based on the Earth's orbit. So if I break that connection and I look at this, I have an input node is set to 0, and input node 2 is set to 0. The minute I occupy one of those nodes, and it really doesn't matter which one I use here, that node goes away in the Attributes Manager. Okay? And what I want to do is I want to take the real number, I want to multiply it by whatever my orbital factor is. And so for Mercury, as I mentioned in the Microsoft Word document, I'm going to multiply that by 4. Okay, so it's going to orbit 4 times faster, or rotate according to Cinema 4D 4 times faster than the Earth orbit rotation. Whew, let's see if that works. Let's close that. I'm going to rewind. I'm going to hit play, and look at that, working like a champ. Okay, that's the basic strategy here. It's going to take you a while to kind of work out the numbers. Don't be terrified. This is a lot of information that I just threw at you. That Espresso, it's kind of new stuff, and there's a lot of things to dig through in Espresso. But I promise you it's going to be smooth sailing here with the Espresso stuff. And I'll review this again one more time, and I'll set up my whole solar system animation dependent on Earth. And the nice thing about this is that, you know, right now I'm animating over 90 frames, but all I have to do is just extend that Earth animation more frames, and everything else falls into line proportionately based on that animation. So that's the real strength here. So that's the basic concept for this. I'm going to spend a lot of time showing you a little bit of workflow at the tail end of this presentation to get my solar system to look better than it does, and to kind of tweak some of the Espresso stuff. And then we'll start talking about narrative. What's the story here? Why are we animating this thing? And we'll build that for presentation. But this kind of concludes the core concept that we want to focus on, the new core concept. And then for the tail end of this presentation, the solar system presentation, we're really going to focus on the design, the presentation, kind of tweaking the values, reviewing and reinforcing some of the things that we already know and that we've already learned up through Espresso. So have fun with this project. Look for some more videos to roll out here real soon, and post any questions that you have back in the discussion board. And also get your works in progress as these things come out back into the discussion board as soon as possible. We have several weeks to work on this project, and we're going to, use as much of it we can to come up with some really great presentations. Have fun. I look forward to seeing the work.